Hey everybody, today we're going to just chat a little bit about some cardiac things. And one of the things I want to talk to you about, and I know this drawing's not very good, one of these days I need to take an art class, is what we call afterload. And afterload, if we look and we say that this is the right atrium, and then this is the right ventricle, and this is going to be the left atrium, and then the last one down here would be the left ventricle. We're going to leave that one blank because we're actually going to put the aortic arch coming up and out of there. And what we need to realize is that the afterload is going to be the pressure that it takes to open up the valves right here that are coming out of this left ventricle. So if you have a pressure of 120 over 80 as a blood pressure, realize what that means is that there is 80 millimeters of mercury pressing back on that valve. So in order for that ventricle to actually push blood out of there, we're going to need to see a pressure of at least 81 millimeters of mercury. So then comes the problem, because we know that cardiac is similar to skeletal muscle. So as somebody's blood pressure goes up, and let's say we get them up to a 180 over 100, so there's been a 20% increase. Now what we're going to see is that that back pressure is now at 100, thereby putting a greater load on that left ventricle and therefore hypertrophying that left ventricle. And then in doing so, with that hypertrophy, what we're going to see is we're going to see an increase in muscle growth, thereby reducing the size of the chamber in here. And once we do that, somebody's going to go from a 60 beats per minute to a 90 or so beats per minute in order to still get the same blood flow going out, now out of a smaller chamber.